problem, we have a slightly different situation, and I want you to see if you can figure out where our difference comes from. A new breed of peacock is developed by artificial selection for a novel mutation in feather color. This variant has purple instead of blue neck, chest, and head feathers. Because the breeder's been studying and selectively breeding his population, he knows that the purple allele occurs at a frequency of 0.1. He thinks that the new allele is recessive. What is the frequency of homozygous and heterozygous and homozygous purple individuals that could be used to produce more purple peacocks? So, step 1, have we been given a phenotype or an allele frequency? We have been given an allele frequency. The purple allele occurs at a frequency of 0.1. We are also told that the new allele, the purple allele, is recessive. That means we're going to set Q equal to 0.1. From here, we can calculate P. So P is going to be equal to 1 minus Q. Remember, P plus Q equals 1. So P plus Q equals 1. 1 minus Q equals P. So P is equal to 1 minus 0.1. So P is equal to 0.9. So now we've got all the information we need to now calculate some genotype frequencies. So the question asks for the frequency of heterozygous and homozygous purple. Now our heterozygous individuals are actually going to be blue, right? Because they are displaying the dominant allele. But they can be used to produce more purple peacocks. So if we're going to calculate the frequency of heterozygous, that's 2PQ, 2 times 0.9 times 0.1. So the frequency of our heterozygous individuals is 0.18. So that means 18% of the population that he has are blue, but could produce purple offspring. Now, that doesn't mean that he knows which individuals are heterozygous. It just means that those individuals could be used to produce purple offspring. We also need to calculate the, see if I got a purple here, the frequency of the purple allele, the homozygous purple individuals. So that is going to be equal to Q squared, because this homozygous purple is a phenotype frequency, and it is the recessive phenotype. So for this one, we're going to calculate Q squared. So Q squared is equal to 0.1 squared. So Q squared is equal to 0.01. This means that 1% of his population are going to be purple. So there's a quite small number of individuals with this purple allele, but if he is using artificial selection, he can select out those purple individuals and selectively breed those to increase the number of purple peacocks in his population.